Top gas recycling in blast furnace operations can dramatically reduce our carbon footprint and align our steel making with sustainability goals. Now, let's explore this breakthrough together. So, we know that steel contributes around a huge global CO2 emission, which is around not less than 8% in any case. So, with evolving environmental regulation and climate targets, especially in EU and India, it is very critical that we adopt transformative low carbon solution. Otherwise, there is no way out in surviving steel industry. Now, coming to the top gas recycling capture, the gas exiting from the furnace. Now, what happens here? We remove CO2 and recycle the carbon monoxide and hydrogen back into the furnace. As we know, carbon monoxide and hydrogen primarily constitute main reducing element of gas. So these boost efficiency and significantly cut emission. Here is a direct comparison between conventional and top gas recovery blast furnaces. Note that here what we used to do, whatever the outgoing gas is coming out of conventional blast furnace is uh, is filtered by CO2, and thereafter the remaining gases which concentrate more in CO and hydrogen recycled back to blast furnaces. So, due to these phenomena, a comparison is shown where gas right from gas composition, as you can see that in conventional blast furnace, our gas composition primarily configured with a nitrogen, and where the top gas recycled blast furnace having got a CO and hydrogen rich as CO2 is filtered out. Now, in the top gas recovery system, the top gas is cleaned, CO2 is removed using VPSA, then remaining CO and hydrogen are heated and sent back to the shaft over 2 years. It depends how we are planning our furnaces with some retrofit design or the very conventional blast furnaces. And then oxygen is injected instead of air to avoid nitrogen dilution. So this takes a, a shape of efficient reactor now compared to our conventional blast furnace. As we have shown a outline sketch of VPSA system, that is vacuum pressure swing adsorption system, this selectively removes CO2 at low pressure. It's essential for achieving high purity reducing gas for effective recycling, because almost our outgoing gases from VPSA must not have CO2, because injecting CO2 again in a two-year system will create heat sink in the furnace. As we know, this CO2 is reverted back to CO but at expense of a huge thermal deficit and which is dangerous for blast furnace. Hence, we must have to ensure that the outgoing gases after getting processed through VPSA system is almost free of CO2. Now, coming to the energy efficiency and mass utilization, which is also an important part of this study, and we can see that the conventional blast furnace and the top gas recycled blast furnace is um, uh, shown here. Here we can see that the in terms of net efficiency and which shows that TGR improves both energy efficiency and mass utilization. The recycling loop adds 5 to 6 gigajoule of chemical energy, reducing dependency on solid fuels. So now to adopt this system, we must have to be careful about our stoves because once the gas is getting inserted back in the stove after recovering our top gas, it is also essential, it should be also concerned, uh, matter of a great concern rather, how to supplement the sensible heat to the blast furnace. That means we need to heat up our stoves. Now our heating of stoves also need almost 15 to 20% of top gas volume in order to provide the required blast temperature of 1200 degrees centigrade minimum. And in this top recovery setup, our blast temperature has a huge role because now our blast temperature is to increase tremendously in order to combat the heat sink created by our top gas recycling system, which need to be heated to a huge temperature because it is almost getting entered in the stack region. So if it's getting heated, reduction potential will improve a lot. So we can say that to adopt a stove for TGR, we have to use this clean CO and S2 gas instead of raw BF gas, and we must have to ensure that with oxygen it has a complete combustion and maintain our target 1200 degrees centigrade for hot blast delivery. So this is one of the most important aspects of our TGR adaptation for our stoves. Now, yeah, as these outgoing gases is being recycled in the system back, dust is also one of the very important parameter that need to be considered each and every steps. Now, dust collected during gas cleaning contains valuable Fe and C. So instead of landfilling, we should recover and recycle these back to the sinter plant or through briquettes. That will be good as this system is getting back to the stack region. This is one of the most important activity. As for the top gas recovery directly support carbon reduction, it cuts coke cost and it also reduces our waste as we have just seen in the preceding slide. mm, we are also recycling our waste like carbon or Fe particles. It positions the company as a forward looking and sustainable steel producer. So we can talk about the real picture, that is a practical roadmap here, that is from feasibility study and modeling to installing VPSA unit, adapting hardware and eventually implementing the system in full scale. Hence, we can say that top gas recycling is not just a concept, it's a proven, practical, and aligned perfectly with our sustainability and economical goals. It's the time we move forward and make it part of our blast furnace operation. Thank you.